Chapter 2, Lesson 1, Solving Linear Equations and Inequalities. Simplify each expression. 2x plus 5 minus 3x. Here we have like terms like 2x and 3x. So first combine like terms. 2x minus 3x equals negative x plus 5. Number 2, negative bracket w minus 2. Distribute minus on bracket, so minus w plus 2, because minus minus is positive. So minus w plus 2. Number 3, 6 times 2 and 6 times 3g. 6 times 2 equals 18, and 6 times negative 3g equals minus 18g. Graph from number line. T greater than negative 2. T greater than negative 2. Where is negative 2? Negative 2 is here, but it's greater than only, not greater than or equal. So circle, draw circle on negative 2, but it's opened because negative 2 is not included, and then greater than in the positive direction, in the right direction. So from negative 2 open to positive infinity. Is 2 a solution of the inequality negative 2 smaller than negative 6? Is 2 a solution? When 2 is substituted for x, if we put x negative 2, so negative 2 times negative 2 is 4. Does 4 smaller than negative 6? 4 is smaller than negative 6. 4 is greater than negative 6. So 2 does not satisfy this inequality. When 2 is substituted for x, the inequality is false because negative 4 is not smaller than negative 6. An equation is a mathematical statement that two expressions are equivalent. The solution set of an equation is the value or values of the variables that make the equation true. A linear equation in one variable can be written in the form ax equals b, where a and b are constants and a doesn't equal 0. Linear equation in one variable, like 4x equals 8, 3x minus 2 over 3x equals negative 9, 2x minus 5 equals 0.1x plus 2. These equations are linear equations in one variable. Non-linear equation like these equations: 3 root x plus 1 equals 32, 2 over x squared plus 1 equals 41, 3 minus 2 power x equals negative 5. So non-linear equation if x underneath a square root like the first equation, or if x has a negative power because x is down, so if we make it up, so we will switch sign of power, so it will be 2x power negative 2 plus 1, and if x in exponent. So all of these equations are non-linear equations. Notice that the variable in a linear equation is not under a radical sign and is not raised to a power other than 1. The variable is also not an exponent and is not in denominator. Solving a linear equation requires isolating the variable on one side of the equation by using the properties of equality. Properties of equality. Addition. If you add the same quantity to both sides of an equation, the equation will still be true. Like here, 3 equals 3. So if we add 2 to both sides, so 5 equals 5. So if we have A equals B, if we add C to both sides, the equation will still be true. And also if you subtract the same quantity from both sides of an equation, the equation will still be true, like 3 minus 2 equals 3 minus 2. So if A equals to B, so A minus C equals B minus C. And also in multiplication, if you multiply both sides of an equation by same quantity, the equation will still be true. 3 equals 3. If we multiply by 2 to both sides, 3 times 2 equals 6 and 3 times 2 equals 6. So the formula, if A equals B, so AC equals BC. If you divide both sides of an equation by same non-zero quantity, it should be non-zero quantity, the equation will still be true. So 3 equals 3, 3 divided 2 equals 3 divided 2. But the condition C doesn't equals 0. To isolate the variable, perform the inverse of opposite of every operation in the equation on both sides of equation. Do inverse operations in the reverse order of operations. The local phone company charges $12.95 a month for the first 200 of airtime plus 0.07 for each additional minute. Again, the local phone company charges $12.95 a month for the first 200 of airtime plus 0.07 for each additional minute. If Nina's bill for the month was 14.56, how many additional minutes did she use? So first we have to put the formula, we have to make the equation. Let M represent the number of additional minutes that Nina used. So monthly charge plus additional minute charge times the number of additional minutes equals total charge. The total charge equals monthly charge, which is constant. Monthly charge is constant plus additional minute charge times number of additional minutes. The total charge here is given 14.56 and the monthly charge is given 12.95 plus 0.07 times M number of minutes. Now it's equation. So 12.95 plus 0.7 M equals 14.56. Subtract 12.95 from both sides. So 0.07 equals 14 minus 56 minus 12.95 equals 1.61. Now divide both sides by 0.07. So m equals 1.61 divided by 0.07. Now m equals 23, so Nina used 23 additional minutes. State the cups are to be placed in a pantry. One cup is 3.25 high, and each additional cup raises the stake 0.25 inch. How many cups fit between two shelves 14 inch apart? First, we should put the equation. Let's say represent the number of additional cups needed. So model 1 cup plus additional cup height times numbers of additional cups equals total height. So again, total height equals 1 cup plus additional cup height times number of additional cups. 3.25 plus 0.25 times C equals 14. So now it's equation solve. 3.25 plus 0.25 C equals 14. Subtract 3.25 from both sides. So 0.25 C equals 14 minus 3.25, which equals 10.75. 10.75. Now divide both sides by 0.25. So C equals 10.75 divided by 25 equals 43. So now 44 cups fit between the 14 inch shelves. Solving equations with the distributive property. Solve 4 bracket m plus 12 equals minus 36. First, the quantity m plus 12 is multiplied by 4, so divided by 4 first. So m plus 12 equals minus 36 divided by 4. So m plus 12 equals negative 9. Now m plus 12 equals negative 9. Subtract 12 from both sides. So m equals minus 12 minus 9 minus 12 equals negative 21. So m equals negative 21. Check 4 times m plus 12 equals negative 36. And we said that m equals negative 21, so replace m by negative 21. So 4 times negative 21 plus 12. Negative 21 plus 12 equals negative 9. So negative 9 times 4 equals minus 36. So the answer is right. Solve 4 times m plus 12 equals minus 36, but by another method. Distribute before solving. So we can distribute 4 on bracket 4 times m and 4 times 12. 4 times m equals 4m and 4 times 12 equals 48 equals minus 36. Now subtract 48 from both sides. So So 4m equals minus 36 minus 48. So 4m equals negative 84 minus 36 minus 48 equals negative 84. Divide both sides by 4, so m equals negative 84 divided by 4 equals negative 21. This is the second method. Solve 3 times 2 minus 3p equals 42. Method 1. Divide both sides by 3. So 2 minus 3p equals 42 divided by 3, which equals 14. So 2 minus 3b equals 14. Now we can subtract 2 from both sides. So negative 3p equals 12 minus 2, which equals 14 minus 2, which equals 12. Now we can divide both sides by negative 3. So p equals 12 divided by negative 3 equals negative 4. Check it out. 3 bracket 2 minus 3p equals 42. If we replace if we replace p by 4, so 3 bracket 2 minus negative 3 times negative 4 equals positive 12. Now 3 times 2 6 and 3 times 12 36, which equals 42. Method 2. Distribute before solving. Distribute 3 on this bracket, so 3 times 2 equals 6. 3 times 3 equals 9p equals 42. Subtract 6 from both sides, so negative 9b equals 42 minus 6 equals 36. Now divide by negative 9, so p equals 36 divided by negative 9 equals negative 4. Solve. Negative 3 times 5 minus 4r equals negative 9. Method 1. Divided by negative 3. So 5 minus 4r equals negative 9 divided by negative 3 equals 3. So 5 minus 4r equals 3. Now subtract 5 from both sides. Negative 4r equals 3 minus 5 equals negative 2. Negative 4r equals negative 2. Divide by negative 4. So r equals half. If we replace r by half to check, so negative 3 bracket 5 minus 4 times half, which equals 2, then 5 minus 2 equals 3, then negative 3 times 3 equals negative 9. Method 2. Distribute before solving, so negative 3 times 5 negative 15, negative 3 times negative 4r equals positive 12r equals negative 9. Now add 15 to both sides. So 12r equals negative 9 plus 15 equals 6. 12r equals 6. Now divide by 12. So r equals 6 divided 12 equals half. If there are variables on both sides of the equation, 1. Simplify each side. 2. Collect all variables terms on one side and all constants terms on the other side. 3. Isolate the variables as you did in the previous problems. 3k minus 14k plus 25 equals 2 minus 6k minus 12. Simplify each side by combining like terms. We have here 3k minus 14k, which equals negative 11k. And on the other side, we have like terms 2 and negative 12. 2 minus 12 equals negative 10. Collect variables on the right side. So we can get negative 6k from this side to this side by opposite sign. Or we can add 11k to both sides. So 25 equals 5k minus 10. Collect constants on the left side. So 25 plus 10 equals 35. So 35 equals 5k. Now we can divide both sides by 5. So k equals 7. Three times w plus 7 minus 5w equals w plus 12. Simplify each side by combining like terms. So 3 times w equals 3w. 3 times 7 equals 21. So we have 3w minus 5w equals negative 2w plus 21. Collect variables on the right side. So add 2w here, 2w here. So 3w plus 12 equals 21. Collect constants on the left sides. So subtract 12. 21 minus 12 equals 9 equals 3w. Now divide by 3. W equals 3. You have solved equations that have a single solution. Equations may also have infinitely many solutions or no solution. An equation that is true for all values of the variable such as x equals x is an identity. An equation that has no solution such as 3 equals 5 is a contradiction because there are no values that make it true. For example, 3v minus 9 minus 4v equals negative 5 plus w. Simplify 3v minus 4v equals negative v and distribute negative on this bracket, so negative 5 plus v. Switch the sign. Now plus v, so negative 9 doesn't equals negative 5, so it's a contradiction. The equation has no solution. The solution set is an empty set, which is represented by the symbol phi. If the equation has no solution, so we can represent it by symbol phi. Two times x equals 2x minus 12, and negative 5x plus 7x equals 2x. Now subtract 2x from both sides. So negative 12 equals negative 12, identity. The solution sets is all real numbers, or R. Five times x equals 5x minus 30. 3x plus 2x equals 5x minus 18. Subtract minus 5x from both sides. So negative 30 doesn't equal negative 18, contradiction, and the solution is phi. Three times 2 equals 6. 3 times 3x minus 9x. Negative 2 times x, negative 2x, negative 2 times negative 3 plus 6, so negative 2x minus 7x minus 9x. Add 9x to both sides, so 6 equals 6, identity, and the solution set is all real numbers, or R. An inequality is a statement that compares two expressions by using the symbol smaller than, greater than, smaller than or equal, greater than or equal, or does not equal. The graph of the inequality is the solution set, the set of all points on the number line that satisfies the inequality. The properties of the equality are true for inequalities, with one important difference: if you multiply or divide both sides by a negative number, you must reverse the inequality symbol. 4 smaller than 6, but if we multiply the both sides by negative 2, 4 times negative 2 is negative 8. 6 times negative 2 is 12. It's negative 12. Now, negative 8 is greater than negative 12. So, if we multiply it by a negative number, you have to switch the sign of inequality. A smaller than B. If you multiplied by C here and here, but C is negative, so AC greater than BC. We have to switch the sign. And also in division, 4 smaller than 6. If you divide it by negative 2 in both sides, so negative 2 and negative 3, but negative 3 is greater than. So we have to switch the sign. These properties also apply to inequalities expressed with greater than or equal and smaller than or equal. Eight a minus 2 greater than 13a plus 8. Subtract 13a, so 5a, negative 5a minus 2 greater than 8. Now add 2, so negative 5a greater than 10. Now divided by negative 5 here and here, so a in this side and negative 2 in this side, but we divided by negative, so switch the sign. Greater than will be smaller than or equal. To check this inequality, test negative 4. If we put negative 4 in the place of a here and here, so negative 34 greater than negative 44, so negative 4 is the solution. Test negative 2, negative 18, and negative 18, and it's equal, so negative 2 is the solution. Test negative 1, negative 10 greater than or equals negative 5. It's not true, so negative 1 is not a solution. X plus 8 greater than 4x plus 17. Subtract x from both sides, so 8 greater than or equal 3x plus 17. Subtract 17 from both sides. Now 3x smaller than or equal negative 9. Divide by 3. So x smaller than negative 3 in this form or in this form. Check. Test negative 6 is a solution. Negative 3 is a solution, but 0 is not a solution.
Lesson 2, Proportional Reasoning. Write as a decimal and a percent. 2 over 5. 2 over 5 is a number as a fraction. To convert it to a decimal, you can use calculator. 2 over 5 equals 0.4. And to make it a percentage, you can multiply by 100. 0.4 or 2 over 5 times 100 equals 40. 40%. 15 over 8 equals 1.875. Then, to make it as a percentage, multiply one of these numbers by 100. So the answer equals 187.5%. Graph on a coordinate plane. A is a point, negative 1 and 2. B, 0 and negative 3. Negative 1 on x here, and then up till 2. So point negative 1 and 2 in this point. 0 and negative 3, 0 on x, and then move 3 units down, 1, 2, 3. B, 0 and negative 3. The distance from Max's house to the park is 3.5. What is the distance in feet? 3.5 mile. So from mile to feet, multiply by 5,280. We have 3.5 miles, so 3.5 times 5,280 equals 18,480 feet. Recall that a ratio is a comparison of two numbers by division, and the proportional is an equation stating that two ratios are equal. Ratio is a comparison of two numbers by division, but proportion is an equation stating that two ratios are equal. In a proportion, the cross products are equal. The cross product of a proportion are equal. If we have 3 over 5, 3 over 5 only is a ratio. 3 over 5 only is a ratio. 9 over 15 only is a ratio. But here we have 3 over 5 equals 9 over 15. So we have equality of two ratios. So it's a proportion. It's a proportion. Now the cross product of a proportion are equal. 3 times 5 equals 9 times 5. 9 times 5, 45, and 3 times 15 equals 45. So the cross products of a proportion are equals. For real numbers A, B, C, and D, where B doesn't equal 0 and D doesn't equal 0, if A over B equals C over D, then the formula is AD equals BC. If a proportion contains a variable, you can cross multiply to solve for the variable. When you set the cross products equal, you create A linear equations that you can solve by using the skills that you learned in 2.1. If A divide B equals C divide D, B and C are means, C, A and D are extremes. In a proportion, the product of means is equal to the product of extremes. Solve. Now we have a variable p. So to find the value of p, you can cross multiply. 16 times 12.9 equals p times 24. Sixteen times 12.9 equals 206.4. 24 times p equals 24p. Now get 24 from this side to this side by division, or divide both sides by 24. P equals 8.6. 14 over 88 equals C over 132. To get the variable C, cross multiply 14 times 132 equals C times 88. C times 88 equals 88C, and 14 times 132 equals 1848. Now divide by 88 on both sides, so C equals 1848 divided 88 equals 21. Another example, solve each proportion by cross multiplication. Y times 84 equals 84y, and 12 times 77 equals 924. And now divide by 84 in both sides. So y equals 11. 15 over x equals 2.5 over 7 by using cross multiply. 2.5 times x equals 2.5x, and 7 times 15 equals 105. Now divide both sides by 2.5. We will find x equals 42. Because percentage can be expressed as a ratio, can use the proportion percent over 100 equals part over whole. To solve percent problems, percent is a ratio, that means per 100, for example 30% equals 30 over 100 or 0.30. 30% equals 30 over 100 or 0.30. A poll taken one day before an election showed that 22.5% of voters planned to vote for a certain candidate if 1,800 voters participated in the poll. How many indicated that they plan to vote for the candidate? You know the percent and the total number of voters, so you are trying to find the part of the whole. The number of voters who are planning to vote for that candidate. We can say percent over 100 equals part over whole. So 22.5 over 100 equals x over whole, which is 1,800. Now cross multiply, so 100x equals 22.5 times 1,800. Divide both sides by 100, so x equals 405. Or we can say 22.5% equals 0.225. We divide it by 100. So percent times whole equals part. Percent times whole equals part. So 0.225 times 1800 equals x. So x equals 405. So 405 voters are planning to vote for that candidate. At Clay High School, 434 students, or 35% of the students, play a sport. How many students does Clay High School have? We can use percent over 100 equals part over whole. So 35 over 100 equals 434 over x. And then cross multiply, so 35x equals 100 times 434, and then divide by 35, so x equals 1240. Or we can say 35% equals 0.35. So percent times whole equals part. So 0.35x equals 434. Now solve for x. So x equals 434 divided by 0.35. So x equals 1240. Clay High School has 1240 students. A rate. A rate is a ratio that involves two different units. You are familiar with many rates, such as miles per hour, words per minute, dollars per gallon, or gasoline. Rates can be helpful in solving many problems. Ryan ran 600 meters and counted 482 strides. How long is Ryan's stride in inches? Use a proportion to find the length of his stride in meters. Write both ratios in 4 meters per strides. So 600 meters over 482 strides equals x meter over 1 stride. Now 600 times 1 equals 600, and 482 times x equals 482x. So x approximately equals 1.224 meters. Convert the stride length in inches. So 39.37 inches over 1 meter. So 124 meters over 1 stride length equals 39.35 inch over 1 m, approximately equals 49 inches over 1 stride length. Ryan's stride length is approximately 49 inches. Luis ran 400 meters in 297 strides. Find his stride length in inches. 400 meter over 297 strides equals x over 1. So x equals 400 divided 297. So x approximately equals 1.35. meter over 1 stride length times 39.37 inch over 1 meter equals 53
inch for one stride length. Similar figures have the same shapes but not necessarily the same size. Two figures are similar if their corresponding angles are congruent and corresponding sides are proportional. So the condition here, we have two conditions. The first, the corresponding angles are congruent. The second, the corresponding sides are proportional. The ratio of the corresponding side lengths of similar figures is often called the scale factor. Triangle XYZ has vertices x 0 and 0, y negative 6 and 9, and z 0 and 9. Triangle XAB is similar to triangle XYZ, with a vertex at B 0 and 3. Graph two triangles on same grid. Height of triangle XAB over height of triangle XYZ equals width of triangle XAB over width of triangle XYZ. So 3 over 9 equals x over 6. So the unknown, which is the width of triangle XAB, equals 3 times 6 over 9. 18 over 9 equals 2. To graph triangle XAB, find the coordinate of A. We draw x, y, z. The width is 2 units and the height is 3. So the coordinate of A is negative 2 and 3. Why? Because the height is 3 and the width is 2. Triangle DEF has vertices D 0 and 0, E negative 6 and 0, and F 0 and negative 4. Triangle DEGH is similar to triangle DEF, with a vertex at G negative 3 and 0. Graph triangle DEF and triangle DGH on the same grid. To find the height of triangle DGH, use a proportion width of triangle DGH over width of triangle DEF equals height of triangle DGH over height of triangle DEF. So 3 over 6 equals x, which is unknown, which is height of triangle DGH over 4. So 3 times 4 divided 6. 3 times 4, 12. 12 divided 6 equals 2. Now, first graph the triangle DGH, and then the width is 3 units and the height is 2. The height is 2 and width is 3. So the point H is 0 and negative 2. The tree in front of Luca's house casts a 6-foot shadow at the same time as the house casts a 22-foot shadow. If the tree is 9 feet tall, how tall is the house? Draw the first with base 6 and height 9, and draw the second with base 22 and height h. And now shadow of tree over height of tree equals shadow of house
over height of house. So shadow of tree 6 over 9 equals shadow of house over height to 22 over height, and then cross multiply 22 times 9 6 times h, and then divide both sides by 6, so h equals 33 feet. 6 foot tall climber casts a 20 foot long shadow at the same time that a tree casts a 90 foot long shadow. How tall is the tree? Shadow of climber over height of climber equals shadow of tree over height of tree. So 20 over 6 equals 90 over h. 20 times h, 20h, and 6 times 90 equals 540. So h equals 27 feet high. Lesson 3, Graphing Linear Functions. Solve each equation for y. 7x plus 2y equals 6. To solve for y, just make y by itself in one side, so move 7x from this side to this side by switching the sign. So 6 minus 7x, and then divided by 2. So y equals negative 7 over 2x plus 3. Y equals negative 2x minus 8. 3 if 3x equals 4y plus 12, solve for y and then put x equals to 0. To solve for y, move 12 from this side to this side, so 3x minus 12, and then divide by 4. And after we make y as a subscript, put x equals to 0, so y equals negative 3. If a line passes through negative 5 and 0 and 0 and 2, then it passes through all but which quadrant? In third quadrant. In fourth quadrant. Functions with a constant rate of change are called linear functions. So a linear function can be written in form fx equals mx plus b, where x is independent variable and m and b are constants. The graph of a linear function is a straight line made up of all points that satisfy y equals fx. For example, determine whether the data set could represent a linear function. Look at x values, negative 2, 0, 2, and 4. We have to check the change in x. From negative 2 to 0, we add 2. And check the change in y, or change in fx. From 2 to 1, we subtract 1. And then from 0 to 2, we add 2. And down we subtract 1. Up we add 2, and down we subtract 1. So between each 2 points, the change in y over change in x equals the change in y over change in x here equal change in y over change in x here. So this function is linear. The rate of a change in y over change in x, is constant. In between each 2 points is negative half. So this function over the data set is linear. Another example, determine whether the data set could represent a linear function. Check up and down, plus 1 and plus 2, add 1 but add down add 4, add 1 but down add 8. So this is not a linear function. Why? Because the rate of change, which is change in fx over change in y, is not constant. The first time it was 2, the second time it was 4, the third time it was 8. So the data set is not linear.
Determine whether the dataset could represent a linear function. Up we add 7, down we subtract 9. Add 7, subtract 9, add 7, subtract 9, so this function is linear. The rate of change, which is change in fx over change in x, is constant and equals negative 9 over 7, so the dataset is linear. Up we subtract 2, down we subtract 4. Up we subtract 2, down we subtract 4. Up we subtract 2, down we subtract 8. The rate of change here is not constant because in the first two times it was negative 4 over negative 2, but in the last time it was negative 8 over negative 2. So the dataset is not linear. The constant rate of change for a linear function is its slope. The rate of change of a linear function is called the slope. So the slope of a linear function is a ratio, which is change in fx over change in x. Or we can say rise over run. So the slope of a line is the same between any 2 points on the line. And you can graph line by using the slope and a point. Graph the line with slope 5 over 2 that passes through negative 1 and negative 3. First plot the point negative 1 and negative 3. Negative 1 and negative 3. And then the slope is 5 over 2. Rise over run equals 5 over 2. So 5 is positive, so we will move up 5, and 2 is positive, so we will move right 2. The slope indicates a rise of 5 and the run of 2, so move up 5 because it's positive and right 2 because it's positive. So up 5, 1, 2, 3, 4, 5, and then right 2, 1, 2. Now we have another point, then match between these 2 points to get the line. Graph the line with a slope negative 3 over 4 that passes through 0 and 2. First plot the points 0 and 2 on a x and y coordinate. And then we notice here that slope is negative 3 over 4. So we can use negative 3 over 4 or 3 over negative 4. And you can move down 3 units and right 4 units, or move up 3 units and left 4 units. Now we have 2 points, then match between these 2 points to get the straight line. Graph the line with a slope 4 over 3 and point 3 and 1. First plot the point 3 and 1 of 3, so move up 4 and right 3 to find another point. Then draw a line through the points. Recall from geometry that 2 points determine a line. Often the easiest points to find are the points where a line crosses the axis. The y-intercept is the y-coordinate of a point where the line crosses the x-axis, and the x-intercept is the coordinate of a point where the line crosses the y-axis. So when the line cuts y, this point is called y-intercept, and when a line cuts the x-axis, so this point is called x-intercept. To find the intercepts of 4x minus 2y equals 16, and to find the x-intercept first, put y equals 0. To find the x-intercept, put y equals 0. So 4x minus 2 times 0 equals 16. So 4x equals 16 and x equals 4. So the x-intercept is 4 and 0. 4 and 0. To find the y-intercept 4x minus 2y equals 16, put x equals 0. So negative 2, y equals 16, so x equals negative 8. So the y-intercept is 0 and negative 8. Now we can plot the x-intercept and y-intercept and the match between them. Find the intercepts of 6x minus 2y equals negative 24 and graph the line. Find the x-intercept first, put y equals 0, so 6x equals negative 24, so x equals negative 4. Find the y-intercept. 6x minus 2y equals negative 24. Put x equals 0, so negative 2y equals negative 24 and y equals 12. So the y-intercept is 0 and 12. Now plot the 2 points, negative 4 and 0 and 0 and 12, and now we have the graph of this function. Linear functions can also be expressed as a linear equation of the form y equals mx plus b when a linear function is written in the form y equals mx plus b. The function is said to be in slope-intercept form. If we have a function in this form, y equals mx plus b, for example y equals 2x plus 7, this form is called slope-intercept form. Because m is the slope of the graph and b is the y-intercept, notice that the slope-intercept form is equation solved for y. Write the function minus 4x plus y equals negative 1 in a slope-intercept form, so make y by itself in any side or solve for y. Solve for y, so y equals positive 4x minus 1. Now we have the equation in a slope-intercept form. The line has y-intercept negative 1, which is b, and slope m equals 4. Plot the point 0 and negative 1. Why? Because the y-intercept is negative 1, so x equals 0 and y is negative 1. 0 and negative 1, and use the slope, move up 4 and move right 1 to get the second point. 1, 2, 3, 4 and move right 1. We can also use calculator, but this method is not important, so we can cancel this method. Write the function in a slope-intercept form. Then we should solve for y. Multiply 4 over 3 after getting 6 in this side by negative x plus 6. So we have in this side 4y, and in this side negative 4 over 3x plus 8. So the y-intercept 8, so the point is 0 and 8, and the slope is negative 4 over 3. So plot the point 0 and 8 and use slope to get the other point. 0 and 8, and then use the slope, move down 4, 1, 2, 3, 4, 1, 2, 3, 4, and then move 3 right, 1, 2, 3. 1, 2, 3, 4, and then 1, 2, 3. Write the function 2x minus y equals 9 in the slope-intercept forms and graph. So solve for y. So negative y equals negative 2x plus 9. multiply both sides by -1. So now we have y-intercept -9 and slope is 2. So the line has y-intercept -9 and the slope 2, which is 2 over 1. So first plot the point 0 and -9 and move up 2 and move right 1. The equation with only one variable can be represented by either a vertical or a horizontal line. A vertical line, if we have x equals a, for example x equals 2, so to graph this line x equals 2, just draw a vertical line, cuts x at 2. So if we have x equals a, draw a vertical line, cuts x at a. And the horizontal line, if y equals 3.5, so draw a horizontal line, cuts y at 3.5. So if we have x equals any number, so it's vertical lines. Y equals any number, so it's horizontal line. Slope of vertical line, all vertical lines has a slope undefined. And all horizontal lines has a slope 0. So x equals 2, vertical or horizontal, it's vertical. The slope is undefined. And we can draw it by draw a straight line, vertical cuts y at 2, cuts x at 2. Y equals -4, it's vertical, and we can draw it by graph straight line cuts y at -4, and the slope is 0. Y equals -5, vertical line, draw line, horizontal line, cuts y at -5. And here draw a vertical line, cuts x at 0.5 here. First the slope is 0 and here slope is undefined.
Lesson 5, Linear Inequalities in two variables. Find the intercepts of each line. 3x plus 2y equals 18. To find x-intercept, put y equals 0. So 3x equals 18 and x equals 6. And to find y-intercept, put x equals 0. So 2y equals 18 and y equals 9. So the x-intercept and y-intercept are 0 and 9, 6 and 0. Here 4x minus y equals 0. Do the same steps. You will find the x-intercept and y-intercept 0 and -8, 2 and 0. 5x plus 10y plus 10 equals 2y. Put x equals 0 and find the value of y, and then put y equals 0 and find the value of x. The points are 0 and 5, -2 and 0. Write the function in a slope-intercept form, then graph 2x plus 3y equals -3. Slope-intercept form, y equals mx plus b. So move 2x to this side by negative 2x minus 3, and then divide both sides by 3. So negative 2 over 3x minus 3 over 3 equals 1. So now we have the function in slope intercept form, and we can graph by using a point or by using the y-intercept, which is 0 and negative 1, 0 and negative 1, and then by using the slope negative 2 over 3, so move down 2 units and then move right 3 units. Linear functions for the basic of linear inequalities. A linear inequality in two variables relates two variables using an inequality symbol such as y greater than 2x minus 4. Its graph is a region of coordinate plane bounded by a line. The line is boundary line. The line is boundary line, which divides the coordinate plane into two regions. For example, y equals 2x minus 4. Y equals 2x minus 4, shown at right, divides the coordinate plane into two parts. When we draw the line, we can notice that we divide the plane into two parts, the first part and the second part. Or where y greater than 2x minus 4 and 1 where y 2x minus smaller than 2x minus 4. This part is y smaller than 2x minus 4, and this part y greater than 2x minus 4, and this line, the boundary line, is y equals 2x minus 4. So now we have the line y equals 2x minus 4. Underneath the line, y smaller than 2x minus 4, and above the line y greater than 2x minus 4. In the coordinate plane, higher points have larger y values, so the region where y greater than 2x minus 4 is above the boundary line where y equals 2x minus 4. To graph y greater than 2x minus 4, make the boundary line solid and shade the region above the line to graph y greater than 2x minus 4. Make the boundary line dashed because y values equals to 2x minus 4. Again, we have this line y equals 2x minus 4. To graph y greater than 2x minus 4, that just shade the region above the line. This region. Shade all of this. Why? Because we want y greater than 2x minus 4. This line is 2x minus 4. So, to graph y greater than 2x minus 4, shade above the line. Shade all of these parts. As we can see, this region is shaded. Graphs an equality y greater than negative 1 over 3x plus 2. First, the boundary line y equals negative 1 over 3x plus 2, which has y-intercept of 2 and slope negative 1 over 3. So first, we are going to use this equation if it's like this inequality if it's like equation. So we can ignore this sign now, and we are going to use this inequality as if it is equation y equals negative 1 over 3x plus 2. We can draw this line by using the method of the previous lesson. Just to start with the y-intercept. Y-intercept here is 2, so the point, plot the point 0 and 2, and then use the slope negative 1 over 3. y move down 1 unit and move right 3 units. Move down 1 and then move right 3. 1, 2, 3. Now graph the boundary line. Then shade the region above the boundary line. Why? Because we want here y greater than. Y greater than. Where is the value of y which is greater than? These values or these values? Of course the values of y which is greater, the value above the line. So now we are going to shade this part. To check, choose a point in the solution region such as 2, 3 and 2 and test it in the inequality. Take any point from this shaded area and put it in the inequality. If this point satisfies the inequality, so this is the right solution. If replace x by 3, replace x by 2 and find the answer. Negative 1 over 3 times 3 is negative 1. Negative 1 plus 2 is 1. So 2 greater than 1. So it's right. Another example. Y smaller than negative 1. First, make it y equals negative 1 and then draw y equals negative 1. A horizontal line cuts y at negative 1 here, and this is the boundary line. Now shade the region down. Check any point like 0 and negative 2. Graph the inequality y greater than 3x minus 2. The boundary line is y equals 3x minus 2, which has a y-intercept of negative 2 and slope 3. Draw a solid line because it is part of region of solution. Now shade the area, this area. Why? Because the value of y here is greater. These values are greater, so shade this part. And choose a point in the solution like negative 3 and 2 and put it in the inequality. We will find that this point satisfies the inequality. If the equation of the boundary line is not in a slope-intercept form, you can choose a test point that is not on the line to determine which region to shade. If the point satisfies the inequality, then shade the region containing that point. Otherwise, shade the other region. It's another solution. Both are right. Graphing linear inequalities using intercepts. We have this inequality 3x plus 4y smaller than 12. Put x equals 0 to find the value of y and put y equals 0 to find the value of x. Now we can get two points which are x and y intercepts. Put x equals 0, so y equals 3. Put y equals 0, so x equals 4. So the 2 points 0 and 3, 4 and 0. Now plot them and match between the 2 points. Now we have the boundary line. The inequality 3x plus 4y smaller than 12. So we change this part, or we can use the second method, which is take any point in this region and take any point in this region. If this point is satisfied, then change this part. If the point here is satisfied the inequality, change the part. So here substitute 0 and 0 into the inequality, because 0 plus 0 is smaller than 12 is true. It changes the region that contains 0 and 0. Many applications of inequalities in two variables use only non-negative values. For the variables graph, only the part of the plane that includes realistic solutions. And don't forget which variables represents which quantity. The school carnival charges $4.5 for adults and $3 for children. The school needs to make at least $135 to cover expenses. Using X as the adult ticket price and Y as a child ticket price, write and graph inequality for the amount the school makes on ticket sale. If 25 child tickets are sold, how many adult tickets must be sold to cover expenses? First, the answer will be in two parts. An inequality graph showing the number of each type of ticket that must be sold to cover expenses, and then the number of adult tickets that must be sold make at least 135 if 25 child tickets are sold. The school sells tickets at 4.5 for adults and 3 for children. The school needs to make at least 135. So let X represent the number of adult tickets and Y represent the number of child tickets. That makes me solved. Write an inequality to represent the situation. Adult price 4.5. Number of adult tickets X. So 4.5 times X. And then we need the price of tickets of children. So we know that the price of ticket 3 and number of child tickets Y, so 3 times Y, and we want the sum of two prices, so 4.5x plus 3y, and we know that we want the value to be greater than 135 or equal 135 or equal. So we can say 4.5x plus 3y greater than or equal 135. Now we have the inequality. And then, by using the previous method, find the x-intercept and y-intercept, put x equals 0 and find y, put y equals 0 and find x. So now we have 2 points, 0, 45, 30 and 0. Graph, and then we can take point here 0, 0 and take any point here. The point, if this point satisfies the inequality, graph this region, and if the point here satisfies the inequality, graph this region. So we are going to shade up. If 25 child tickets are sold, so we are going to replace y by 25, and then move 75 to this side by negative, so 4x greater than 60, and then divide by 45, so x greater than or equal 13.3. At least 14 adult tickets must be sold. Coffee gives away prizes. A larger prize costs the coffee $125 and a small prize costs $40. The coffee will not spend more than 1,500. How many of each prize can be awarded? How many small prizes can be awarded before larger prizes are given away? First, we want to put the inequality. So let x represent the number of small prizes and y represents the number of larger prizes. The total prize not to exceed 1,500. Write the inequality. 40 times x plus 125 times y, and it should be smaller than or equal 1,500, because that we want the total not to exceed 1,500, so the inequality must be smaller than or equal, not more than this value, so it should be smaller than or equal. So the inequality 40x plus 125y smaller than 135. Now it's easy, find x-intercept and y-intercept. Plot them on the graph and match. Check any point up, any point down, and shade the region. If 4 larger prizes are awarded, so 40x plus 125 times 4 is smaller than 1,500. So 40x plus 500 is smaller than 1,500. Move 500 by switching the sign. So 40x greater than 1,000, and x is smaller than 25. Solve the graph. First, to cancel this fraction, multiply both sides by 4 over 3. So 8x minus 2y greater than 8. Now, move 8x to this side by switching its sign. So negative 2y greater than negative 8x plus 8. Now divide by negative 2 here and here, but don't forget to switch the sign of inequality because we divide by negative.
Now we have the inequality y smaller than 4x minus 4.